Hello everyone. I'm Guangxing Han from Columbia University. Today I will share our work on artwork recognition, collaborating with geographers from CTU in Prague. As a part of our instance level recognition workshop, we focus on the artwork domain, in particular museum exhibit. The goal is to recognize the specific artwork in a test image. So to build a data set for artwork recognition, we need to collect both training and testing image sets. For the training set, we use open access images from the Metropolitan Museum of Art with CC0 license. The training set consists of more than 200,000 artworks and totaling more than 400,000 open access images. Each artwork has at least one image and two images on average. The artwork with the largest number of images is an illustrated book that has 2,870 images. As shown in this figure, our training dataset shows long tail distribution, and most of the artwork are few shots. The 200,000 artworks cover a large variety of categories. As shown in this figure, the top 10 category with the maximum number of images. For example, prints, paintings, and the sculptures are among the top categories in our training set. For the test set, we collect users' photos with challenging variations compared to the training set. For example, in the left test training image pair, the two images have large difference in terms of pose and lighting. In the right example, the test image is only part of the training image. In addition, we also use external artwork images. For example, Wikimedia Commons has destructors which do not have ground truth labels in the training set. All of these features makes our artwork dataset extremely challenging. This setup is also the same as the landmark recognition challenge, and macro APs will be used for evaluation. To build a baseline model for artwork recognition, we treat this instance level recognition as search and KN classification as a common practice. Specifically, we use ResNet environments as a model architecture. Then we use global pooling, for example, gene pooling, and normalization techniques, for example, R2Norm, to get the global descriptors for the image. After that, we can use nearest neighborhood search for recognition. This slide summarizes some of the relative data sets in the artwork domain. Some of the data sets only focus on the category level recognition of detection. For example, dog, bird, and house. Some focus on attribute prediction. For example, type of artwork, material, and period. There are mainly two data sets which are closely related to our data set. The first one is the noisy art, which focus on widely supervised instance level recognition. They collect 90,000 noisy images of 9,000 artworks from the web, and only 200 artworks are manually verified. So this data set is a noisy data set. OpenMake, it also deals with instance level classification, but it is much smaller and mainly focused on domain adaptation. Our data sets have some major difference compared to previous work. First, our data set focuses on instance level recognition tasks. The second, our data set has more than 200,000 artworks and 400,000 images, and it's the largest data set so far. Third, we also include destructors from external artwork images, for example, Wikimedia Commons, which make the task much harder. Next, I would like to report the current status of the test set collection. We crawl web images of mat to get a test set and use textual description and manual verification to get clean ground truth. Currently, we have collected about 600 challenging queries. However, most of the lessons are not in the public domain, so it cannot be used in a challenge as attribution is required. Therefore, the first goal is to make a research dataset and not a challenge. For the next step, we can revisit MAT to take photos for the test set as MAT reopens at this time, which is also our initial plan, but postponed by the COVID-19. So to summarize, we extend instance recognition to the artwork domain and build a training set using open access match images, which is large scale and long tailed with more than 200,000 artworks and 400,000 images. We are also working on building large scale and challenging test sets with proper license. Please reach out to us if you would like to contribute to our work. Thank you very much.
Thank you, Guangxing. I think we have some time for questions. Yeah, if you're in the audience, remember that you may use the Q&A feature.
Sorry. Sorry.
So just a comment before, I don't know, like to see if we have any questions. So, okay, this is work, it's ongoing work, and now the goal was to, like show the result of an initiative that started like in the context of this workshop. So another goal is, let's say, to call for possible collaboration. So other than the baseline shown here, like what we target is to provide a rich set of baselines for the final data set, and also as Guangxing showed, like we're still in the process of finalizing the test queries and actually even enriching them by revisiting the initial plan. So
yeah, so currently we focus on using global descriptors to build our baseline model. Yeah. So in the future, maybe we can try to use more complex model to, for example, the local features to build more efficient model.
Yeah, absolutely. I think that would be great. And I have one question is, what, based on your observation of the data, to give also some better idea for the attendees here, what are the main cases, main types of challenges that you see in, comparing tests to training images?
Oh, yeah. So I think the main challenge consists of two parts. So first, the training set is long tail, and most of the artworks are few short. So maybe a traditional softmax would not be work for our data set, because there are so many classes, and each class have very few samples. Yeah. And this is the first challenge. And second is the test set and the training sets has very large variations. For example, the pose and the lighting are very different. Can be very different for the test and training images, and also the test image can only be part of the artwork in the training set. So this is very challenging. And the other is we also use the external artwork images as distractors. So, for example, the one given text image may have no ground truth labels in the training set. So in this way, it is just distractors. So it will make our data set much harder.
Got it. So we have one question from the audience in the Q&A, and Guangxing, if you want to, may also click on the Q&A and read the question yourself, but let me read the question to everyone. So Nan asked, given that you're working on artworks which can share an artist even when they're not the same instance, do you exploit this information? As artist recognition has been relatively often done and works quite well.
Sorry, can you?
Yeah, so basically,
I can try to take that.
Yeah,
I can try. I think what is meant here is whether the artist information, the artist label, will be useful in such a data set. So actually, okay, it can be, or maybe that's something to be explored. And the case is that Met has an API to access all this kind of metadata. So once such a data set is released, probably one can be creative and try to use also such attributes, let's say, in the training process. But otherwise, in the baselines that we're going to consider first, only the instance level label will be used to train a recognition model.